So in this question, you should state clearly the values of the parameters of any normal distribution you use. Okay, so just make sure you state them. So you state them is really for your own good, and also because if the examiner can't really read what you're trying to say, then you will get penalized. So you don't want to put yourself in that disadvantaged position. So over a 3-month period, Ken makes X minutes of peak rate telephone calls and Y minutes of cheap rate calls. So X minutes of peak rate telephone calls and 1 minute of cheap rate calls. Independent random variable distribution of n and 400. And then the standard deviation is 60 and 30, 30 and 60 respectively. So I think yeah, it's already what do you call it? It's already described for you, so you can just use it. So the first one, X is normally distributed of 180 minutes. 30 square. Y is normally of 460 square. Okay, so find the probability that over a 3-month period, which is this X here, the number of minutes of cheap calls is actually Y, is more than twice the number of minutes of peak rate calls, twice. Okay, so meaning now there are only 2 calls involved. So the cheap rate call and the peak rate, which is X1. Okay, so when you see this twice, it's not X1 plus X2. X1 plus X2 means that you have 2 calls of the peak rate calls. There are 2 peak rate calls, but this one is you pick 1 peak rate call and then you just twice it. So it's actually 2x1. This is the one, not this one. Okay. So over the week, a lot of you also ask me what's the difference between them. This is 2 independent variables, meaning 2 calls. This is 1 call, take it out times 2. So the question here is saying take out 1 and then times 2. Okay. Over a 3-month period. Okay, so the required probability what we want is actually the number of minute Y is more than twice. Okay, so this is it. So this is P Y minus 2x and 0. Okay, great. So we know that Y minus 2x normally distributed EY minus 2x would be EY minus 2EX. Variance Y minus 2x. Now variance, remember you need to square the negative 2 in front. So this is it, 2 square variance x. Okay, so just key in calculator here. I'll leave it here. EY 400 minus 2 times 180, that will be 40. And then this is 300 square, 60 square, variance is 30 square. $7,200. So this is 40. And the variance is 7,200. Just key in calculator shouldn't be an issue. It would be just key in calculator, then you just distribution normal CDF. Then what you put is 0, right? Then mu is 40. Remember the root, is 7,200. Just paste it. 0.68132. All right, that's how we do this. So the second one, peak rate calls cost 12 cents per minute. I don't remember when I don't think you all understand how is it like back those days, right? Those days you call people, you're charged by the minute. Nowadays you don't, right? You're charged by the data, right? So cheap calls rate costs 5 cents per minute. So the peak calls cost 12 cents and peak call costs 0.05. The fun part is that over a 3-month period, the total cost of Ken's call is greater than 45. Okay, great. So this case here, please write down. They ask you to indicate and specify the state clearly the values of parameters of any distribution you use, right? So like this, because actually they define x and y for us. So I highly doubt it that they want you to define right now or let x and y be something something. But what they want is this: they want to be able to see that you write this out, because like I said, you write it out not because it's good for them, but it's good for you. You don't write it down nicely, right? You get careless mistake, right? Then they can't award you mark if your intermediate steps are all messed up. So the way you present your question is a lot of times is for your own sake. So part two, don't put the examiner in a very difficult position. That's what I'm saying. It's very hard to be the examiner, because sometimes the ambiguity arises and it's very hard to award the proper mark. So you have let total cost be dollars. Okay, C. Okay. I want to, so we know that you would have peak rate is X, so it's 0.12 times X plus 0.05 times Y. Okay, you probably cheap rate calls cheap is Y, right? Okay, great. So in other words, expectation of C is 0.12, expectation of X plus 0.05, expectation of Y, no issue there. Then variance of C is 0.12 square variance X plus 0.05 square variance Y. Okay, so all this not an issue. I think expectation of X, we have it is 180, and then this is 0.05. Expectation of Y would be 400. Later I'll key in calculator, 0.12 square variance X will be 30 square plus 0.05 square, 60 square. Okay, is $41.6 on average. You would expect his phone bill to be $41.60. Okay, so 0.12 square, it will be 20 with a variance of 21.96. So the required probability P PC bigger than $45. Okay, so just key in calculator. Similarly, you will get the lower is 45, infinity. Then you put this as 41.6. Remember the root it 21 point. Okay, then enter 0.2340. Yep. So for part 3, probably the total peak rate calls. So we just want peak rate. We just want the peak rate calls of 2 independent 3-month period is greater than 45. So for part 3, we just need the peak rate. Okay, so the peak rate calls would be the total calls. Let total cost of peak rate calls be T total cost. So we have 0.1. Right, peak rate is 12 cents per minute, right? X1 plus 0.12 X2. Okay, this is so you have the first 3 months of peak rate and the second month. So in other words, we have expectation plus 0.12 expectation X2. Well, I think it's pretty good. This case here, we get to revise some of the random variables here. So 0.12 expectation of X, which is be 180, right? So times 2, that will be 43.2. Okay, then variance T will just be 0.12 square variance X1 this is plus 12 square variance X2 price of 0.12 square variance X, then that will be twice of 0.12 square variance X is 30 square, 2 times 0.1 square, there will be 25.92. So what we do here is the required probability is more than 45. So required probability T total more than 45. So T would just be 43.2. Okay. So hopefully no matter so here we'll get normal CDF 45, 43.2, 25.92. 0.3618. Yay. Thank you.